Alright, so we're going to begin chapter 3, and we're going to get into dealing with polynomial functions and rational functions throughout this section. And we're going to talk about some graphing, we're going to talk about a number of different things. And like I try to do with most things, I want to start kind of basic and then build from there. And so we're going to jump right in. This section, or this chapter, has 4 sections. This first video will cover part of section 3.1, followed by another video or two, and then we'll get into some other sections later. So section 3.1 is going to deal with polynomial functions. And so you need to know what a polynomial function is. And this definition is from the book. It is kind of wordy, probably doesn't mean a lot to you. It says that a polynomial function, we'll call it f of degree n, where n is a non-negative integer, is given by this notation. Now, again, that doesn't mean a lot to you probably. However, you know what polynomials look like. You know what a trinomial is, for example, and you know what a polynomial that has 4 or 5 terms might look like. That's stuff you've done before. And so we're going to be dealing with polynomials, but they're specifically going to be a function. So you're not going to have anything here that's not a function. And so just be aware of that as we are moving forward throughout this section. So some basic polynomial functions that we're going to talk about. We have what we call the constant function, where y is equal to a number, or f of x is equal to a number. So this would be a graph like y equals 3, okay, or an equation that would be y equals 3. We've talked about in previous sections. In chapter 2, we talked about how to graph that. And we said that if it's y equals 3, for example, the y-intercept is 3, and then it doesn't have an x-intercept. And so it's parallel to the x-axis, so it's a horizontal line. And so we've talked about some of that, and we're going to continue to build on some of those ideas as we move forward. Now, the next type that we have is what we call a linear function. This is one, again, that you've seen. Chapter 2, we dealt with linear functions a good bit. And so you're going to continue to see linear functions a little bit here. We've also talked about quadratic functions. Again, you can see an example there. A quadratic function has this power of 2, and we know that's going to be a parabola type shape. We'll talk more about that specifically in just a few minutes. And then there's also the cubic equation. This is one that has a power of 3. Remember the degree being important, because the degree tells us how many solutions there would be, how many zeros there are going to be. We'll talk more about that again moving forward. And then a quartic function is one that has a degree of 4. And again, you can see an example there. And so as we go through this chapter, and this, especially this first section, and we talk about graphing a little bit, we're going to talk about these different types of graphs and what they look like, and how they are shifted or adjusted from what we call the parent graph. Okay, so kind of just to kind of give you an idea about what we're looking at. Now, another part of each of these functions that you need to be aware of are what we call the leading coefficient. That is this number at the front of the polynomial. So the 2, the 5, the 4, the 2, and then the understood 1. Those are the leading coefficient. That number is going to tell us some stuff. And so as we look at this, we need to understand that number is going to be important. So when we talk about the leading coefficient, you're going to know hopefully what number we're talking about. So when we talk about a quadratic functions, we've solved quadratic equations a good bit. We've kind of talked a little bit about their graphs, but not to the extent that we're fixing to. And so a quadratic function is in this basic form: f of x equals ax squared plus bx plus c. And that is very similar to the form that a quadratic equation is written in. And there is a connection between quadratic equations that we've solved before and this type of function. And so we'll kind of connect all those dots, hopefully for you, in just a little while. So the simplest quadratic function is this function f of x equals x squared. It's quadratic because it has the power of 2, and there's nothing else to it, okay? And its graph is going to look like this one, where it has a bottom point, we'll name it in a few minutes, it's called the vertex, where that point is at the origin, and then it's made up of these points, and it has this shape. Now, if we look at a table, which is the only way right now that we know how to graph anything besides lines, if we look at the table and you were to put those numbers in, well, you know that if you square -2, you get 4. And if you square -1, you get 1. If you square 0, you get 0. If you square 1, you get 1. If you square 2, you get 4. And so that's where each of these order pairs come from. Okay? This is what we know as the parent graph. This is the most basic quadratic function that you could have. And so as we talk about quadratic functions, we need to understand that they could be shifted right or left. They could be shifted up or down. They could be wider. They could be more narrow. They could flip upside down. This function can change in a lot of ways, and so our equation is going to give us that information. And so as we talk through this chapter, we're going to talk specifically about quadratic functions and how they change. Now, also something you need to know about a parabola. This shape that a quadratic function makes is that it has what we call an axis of symmetry. And it is this dotted line that you see here in this first one. You can see that. This line that splits this parabola in two symmetric parts. When we say symmetric, we mean if you were to fold this parabola along that line, if you were to, let's say, have this on a piece of paper and you were to fold this piece of paper along that line, the right side would lie on top of the left side, or vice versa. You see the same thing with the one that opens down here on the right. It also has an axis of symmetry. Every parabola has an axis of symmetry because both sides of it, from that vertex, that minimum point here at the bottom or that maximum point here at the top, that vertex is where it starts, and then it symmetrically either opens up or opens down. If it goes up, we say it opens up. If it goes down, we say it opens down. And so we're going to talk about how to find this axis of symmetry. We're going to talk about how to find the vertex, because those are two important things that if we can find that, then our graphing of parabolas becomes pretty simple. Okay, so again, we're going to see that here in just a minute. So, if we compare the basic graph of f of x equals x squared, that parent graph of a parabola, if we compare that to this form, that form can give us a lot of information about the parabola. So, if you look at the form here, the a number is that leading coefficient. That number is going to tell us if the graph opens up or down. If it's positive, the graph will open up. If it's negative, it opens down. If that number has an absolute value that is greater than 1, so let's say that number is a 2 or a 5 or 6 or something of that sort, then that tells us that it's going to be vertically stretched. In other words, that parabola is going to get more narrow. Okay? Because you think about if you were to take that basic graph, this one, and if you were to stretch this vertex down in this direction, mark that where you can see it. If you were to stretch that down, you can imagine that's going to get more narrow, right? And so that's what we're talking about. That a number is going to tell us if it gets more narrow. If the absolute value of that number is between 0 and 1, so it's a fraction, essentially, between 0 and 1, then that tells us it's going to be compressed or shrunk vertically. So kind of squatted down, which is going to make the parabola get wider. Okay? So again, if we go back and we look at this parent graph, if you were to take this vertex and shift it up, well, you can imagine that's going to make this parabola get wider, right? Because you're pushing it all together. You're kind of shrinking it all vertically. And so when that happens, then our graph is going to be a wider parabola. And so that's what the first number tells us. Now, this x minus h quantity squared, if the h is 0, then it's just x squared, okay? And so if it's x minus h, then it means that there's some shift, horizontal shift. If the h is positive, now notice that it's x minus h, so we're only talking about this number. If that is positive, then we're going to shift this parabola to the right. Okay? If that number is a negative, then we're going to shift it left. Now, if it's a negative, understand it will be x minus a negative, which would make that be a positive. So if you see x plus some number, then we're looking at the opposite of that. So it's going to shift the opposite of what you would think. If you look at this number originally, let's say, just to give you an example, if the equation was that, for example, well, this -3 tells us we're going to shift the opposite of what you would think. You might think you go left, but you actually go right, because our form is x minus that number. So it's x minus 3. 3 is actually what we're looking at that says go right. If it were this, well, this 3 is going to tell us to shift left, because again, it's really a minus a -3, and this -3 tells us we're shifting left. Okay, so just be careful there. That can be sort of confusing, and without being in person to show you what we're talking about, that can be somewhat complicated, so just be careful. And then the last number, this k number, tells us how much it's going to shift vertically, up and down. So if that number's positive, it shifts up. If that number's negative, it's going to shift down. And so if we can get our equation to be in this form, well, that's really great, because then that's going to allow us to know how the parabola shifts, how it opens up or down, how it opens wide versus narrow. And so all of those things will be something that will be useful to us when we talk about how to graph. So let's try to graph this one by plotting points. At this point, this is the only way we know how to graph a quadratic. We're simply going to make a t-table and plot some points. Now, it is a parabola shape. We know that because of the power of 2. It's a quadratic. And we know that the parent graph starts at the origin, right? So it makes sense, I hope, that we probably need to start with our x value at 0 to see, is this where it's going to start? And I'm also going to put in 1 for x and -1 for x. And the reason I'm going to do that is because if this is a parabola shape, I've got to get the curve. I've got to see where that curve takes place. And so if it still is sitting at the origin, then I'm going to be able to see that. If it's not sitting at the origin, then I'm going to very easily be able to see what it's doing right or left. And so we know it should open up, and so we might be able to use that to give us some information. So let's try it. Let's take 0 and put it into the equation. And so we have 0 squared plus 4 times 0 minus 4. Well, 0 squared is 0. 4 times 0 is 0 minus 4, which gives us -4 for that solution. Okay? So there's 1 point. We look at putting in +1. And I'm just going to put it here under this one. We have 4 times 1 minus 4. Well, 1 squared is 1. 4 times 1 is 4 minus 4. And so 1 plus 4 is 5. 5 minus 4 is 1. Okay? And then we're going to put negative 1 in. So if we put negative 1 in, we have negative 1 squared plus 4 times negative 1 minus 4. Negative 1 squared is 1. 4 times negative 1 is negative 4. And then minus 4. Well, 1 minus 4 is negative 3. Negative 3 minus 4 is negative 7. Now, if that gives us the curve, great. If it doesn't give us the curve, then we're going to need more points. Okay, so let's plot each of these and see what happens. So 0, negative 4 says we're not going to go right or left any, but we're going to go down 4. And so on our graph, that's going to be this point. Our next order pair is 1, 1. We're going to go right 1 and up 1. And then our next order pair is negative 1, negative 7. So if we go left 1 and down 7, we're going to be at that point. Now, we don't see the curve yet. However, if you'll notice here, because this parabola opens up, we're going to need to choose some other x values going to our left. Because the only way we get a parabola shape, this U shape, if we were to go right, this is going to continue to go up, right? If it does ever go down and our curve takes place, well then we know we've got the wrong graph, because this positive x squared over here tells us it should open up. So what hopefully is going to happen is this parabola shape is going to open up as we move further to our left. So let's put in negative 2 for x. So again, if you take negative 2 squared plus 4 times negative 2 minus 4. Well, negative 2 squared is a positive 4. 4 times negative 2 is negative 8 minus 4. Well, 4 minus 8 is negative 4. Negative 4 minus 4 is negative 8. Okay, so if we plot 2, negative 8, we're going to be here. Now you can begin to see this curve taking place. You can begin to see that curve taking shape, but we haven't seen it go back up yet. And so we need to continue to go to our left with our x value. So let's take negative 3 and substitute it in. And if you take negative 3 and put it in, just like that, negative 3 squared is going to be 9. 4 times negative 3 is negative 12 minus 4. 9 minus 12 is negative 3. Negative 3 minus 4 is negative 7. Well, now you'll notice here and here you see that same value of y. So let's plot this point and we'll talk about it. So we're going to go left 3. We're going to go down 7. Well, now all of a sudden we see that curve, right? And as we connect these points, again, connect them in a smooth curve, it looks something like that. Now, why are these 2 points here and here important as I'm doing this? Well, the reason is because when I see that y value repeat, I know that this graph has reached its minimum point, its vertex, and it's now going the other way back up. Because we know it's symmetric, right? We know it is symmetric where if we were to take this axis of symmetry, I should be able to lie that the right side over on the left side. And so when we do that, we should be able to get these two sides being exactly the same. So when that y value gets repeated, that negative 7 gets repeated, Well, now I know I've gotten to my vertex. Between that, there's a vertex. And so that's what we see in this graph. Now, because it is symmetric, we can also know that if I were to take -4 and put it in, -4 should be at this point. Because, again, it's symmetric with this one over here, right? And if I were to put in -5, it would be at this point because it's symmetric with this one. And so because of that, we're able to get our graph, but we have to get enough to get the curve. Once you see the curve, then we've got enough. You don't have to continue to plot points or continue to plug in numbers. We can do our graph from there. And so you can see that this